Howdy folks, deriving the sum and difference identities for trigonometry. So I have this wonderful rectangle ABCD with a triangle AEF inscribed in it. I'm going to make a couple of labelings here. So I'm going to call this angle alpha. I'm going to call this angle bravo. I'm also going to call the hypotenuse of triangle AEF, so side AF, I'm going to say that is 1 unit. Okay? All right, so using a series of just basic right triangle trigonometry and some properties of angles, I'm going to derive sum and difference identities. So let's get started here. So for triangle AEF, so I'm going to look at triangle AEF. I'm going to take the sine of beta, and I'm looking at this opposite side. So sine of beta equals opposite over hypotenuse, which is just 1, and that means that the opposite side is equal to sine of beta. So making that hypotenuse 1 greatly simplifies our derivation. So I will call this sine of beta. Okay, let's do the same thing with the cosine of beta. Well, that's the adjacent side here. Cosine of beta is adjacent divided by the hypotenuse, which is 1. And so the adjacent side equals cosine of beta. So let's label that. So the adjacent side here is cosine of beta. Let's look at triangle ABE this time. And let's do the same thing except with angle alpha. So I'll do the sine of alpha, and that equals, so the sine value, I'm looking for the opposite side. So the sine of alpha equals opposite. In triangle ABE, the hypotenuse is cosine of beta. So my opposite side equals sine of alpha cosine of beta. Okay, so let me update that. Sine of alpha cosine of beta. Sine of alpha times cosine of beta. There we go. I'm going to also take the cosine of alpha, and I'm looking for this adjacent side. That is adjacent divided by, what's the hypotenuse? Cosine of beta. So that leads me to adjacent side equals cosine of alpha cosine of beta. Okay, so let me fill that in. Cosine of alpha cosine of beta. Okay, good so far? Okay, next one, let me look at this angle here. So I'm going to highlight it. If I highlight this angle, folks, and this angle, well, I know side A, B. Okay, so I'm looking at those two angles. Okay, let me just take that back. I know that AB is parallel to DC. Okay, therefore, what does that tell me about angles? Therefore, it tells me that angle, so if I have a transversal that cuts across two parallel lines, they will form alternate interior angles that are equal. So AB is parallel to DC, okay, with transversal AF. That tells me angle BAF equals angle AFD. So the measure of angle BAF equals the measure of angle AFD. Why is that important? Because then now I can say this angle is alpha plus beta. How do I know that? Well, let me just highlight this. Here's alpha plus beta. Here's alpha plus beta. Okay? All right, why is that important? Well, I'm going to continue with this new angle of alpha plus beta. Now I'm in triangle. Folks, now I'm in triangle AFD. AFD. I'm going to do the whole same process again. Let me do the sine and cosine ratios of this triangle. So sine of alpha plus bravo equals, well, I want this opposite side. So that's opposite divided by, what's the hypotenuse? It's 1. So this tells me that the opposite side equals sine of alpha plus bravo. Sine of alpha, sine of alpha plus bravo. Okay? Oh, come on, neatness. Sine of alpha plus bravo. There we go. Okay? Now let's do the adjacent side. I have cosine of alpha plus bravo. That equals the adjacent side divided by the hypotenuse. So the adjacent side divided by the hypotenuse, that's still 1. And that gives me the adjacent side equals cosine of alpha plus bravo. Okay, so let me fill that in here. This is cosine of alpha plus bravo. Okay, last triangle we need to do here okay, is triangle CEF. Okay, before we do triangle CEF, I need to understand the angles that I'm dealing with here. Okay, so here's the way I look at it. I don't know what this angle is or this angle is, right? All I really need is one angle. And let's find this angle. Well, I think it's alpha, but how do we know it's alpha? Let's reason this out. So I'm going to call this angle K. So in this triangle, I have alpha plus K plus 90. That equals 180 degrees, correct? We know that. We know that also 3 angles along a straight line. So in this case, this straight line right here, K, 90, and question mark. Okay, so on that straight line, I have, where should I put it? Right here. Angle K, K plus 90 degrees. So K plus 90 degrees plus question mark, that also has to equal 180. Well, I just said this part is equal to 180. So alpha, so I'm going to put it this way. I said alpha plus K plus 90 degrees equals 180 degrees. This one, let me rewrite it in order matching, right? So K plus 90 plus alpha equals 180 degrees. This question mark, because both equal 180 degrees, that has to be alpha. So that's why this angle is alpha. Okay? All right. Now that we got that established, let's go back and let's calculate the sine and the cosine ratio for each of these values. Okay, so first, triangle CEF, sine of alpha equals, well, I'm looking for this opposite side. So let me just move all of this. Okay, I'm going to just erase this, folks, right here. I'm going to make some room. Okay, I'm looking for this opposite side here. Sine of alpha equals opposite over, well, the hypotenuse in triangle CEF is sine of beta. So that gives me opposite side equals sine of alpha, sine of beta. Sine of alpha, sine of beta. Okay, let's do the adjacent side here. I'm doing the cosine of alpha, and that equals adjacent divided by, well, the hypotenuse is sine of beta. So my adjacent side is equal to cosine of alpha, sine of beta. Let's fill that in. Cosine of alpha, sine of beta. Okay? All right. What will I do with all this? Okay? What will I do with all this? Let's take a look at let's compare the sides of the rectangles to each other. I have a rectangle. Okay, one thing I will pencil in here is that's a 90-degree angle. So we know that opposite sides of a rectangle, they're not only parallel, but they're also equal in length. So if I look at the vertical sides first, here and here, okay, so if I do AD is equal to BC. So let's first state that AD, the length of AD equals the length of BC. We know that from a rectangle. Let's substitute in for AD. When I do that, AD is sine of alpha plus bravo. And BC, look on the left side, here and here, that is equal to sine of alpha cosine of beta plus cosine of alpha sine of beta. Okay, if you look at your trig identities, your sum identities, this is it right here. Okay, fabulous. Let's do the other side of the triangle. Here, I know that side AB is equal to side DC, and I know this because these are the opposing parallel sides of rectangle are equal. So side AB, that is cosine of alpha cosine of beta equals, well, what's side DC? That is cosine of alpha plus beta plus sine of alpha sine of beta. All right, let me make this look like our cosine sum identity. So let me cosine of alpha, cosine of beta equals, oops, I'm going to subtract this from both sides. So what do I get? Minus sine of alpha, sine of beta equals cosine of alpha plus beta. Let me just write it left to right with the cosine of alpha plus beta on the left side. That equals cosine of alpha, cosine of beta, minus sine of alpha, oops, minus sine of alpha, sine of beta. Okay? This one, and this one. This is our sum identity for sine. This one is our sum identity for cosine. Okay? Well, how do I get the difference identities? For the difference identities, folks, just a subtle manipulation, but we'll show you how this works. So if I start with the sine sum identity, sine of alpha plus alpha plus beta equals sine of alpha cosine of beta plus cosine of alpha sine of beta. Let me turn this into a difference identity by doing this. I'm going to go sine of alpha plus negative beta, and let's make that substitution. So sine of alpha cosine of negative beta plus cosine of alpha sine of negative beta. Okay? The left side is sine of alpha minus beta. There's the format for our difference identity, but what happens on the right side? So off to the side here, right? When I have the sine of negative theta, this is a handy identity to know. This is equal to negative sine of theta. When I have the cosine of negative theta, that is the same as just cosine of theta. Well, I'm going to do a brief segue here. I want you to understand through some graphs. I'm going to draw this out. I want you to understand why this is true. So if I say theta for this one, theta equals pi over 4, what's the sine of pi over 4? That's square root of 2 over 2. Okay? If I do theta this way, where theta equals negative pi over 4, so I'm going clockwise, and we know that's a negative angle, what's the sine of negative pi over 4? Well, it's in quadrant 4. The sine ratio represents the y value. We know that's negative square root of 2 over 2. Okay, so if I line this up, if I say the sine of negative pi over 4 equals, well, I have to adjust the positive version of the angle, sine of pi over 4, by negative 1 so that it's true. Let's take a look. Sine of negative pi over 4 we said is negative square root of 2 over 2 equals negative 1 times what sine of pi over 4? Square root of 2 over 2. So negative square root of 2 over 2 equals negative square root of 2 over 2. Therefore, we can conclude that sine of negative theta equals negative sine of positive theta. Okay, so that's a very important identity right there. That's the first one. Folks, the cosine version. Draw another graph. Call this theta. Theta equals pi over 4. Let's use the same one. What's the cosine of pi over 4? That equals square root of 2 over 2. Let's do theta the other way, where theta equals negative pi over 4. What's the cosine of negative pi over 4, folks? That's cosine of negative pi over 4. I'm still going to the right, my x value. That's still square root of 2 over 2. So what does that tell me? Cosine of negative pi over 4 equals cosine of pi over 4. Well, we know that because square root of 2 over 2 equals square root of 2 over 2. So therefore, in general terms, cosine of negative theta equals cosine of theta. Okay? And that's our second one. Okay, so let's use this to our advantage when I look at sine of negative beta and cosine of negative beta. That equals sine of alpha. What's the cosine of negative beta? Right here. It's just cosine of positive beta plus cosine of alpha. What's sine of negative beta? That's times negative sine of positive beta. Let's finish this up, clean it up. Sine of alpha minus beta equals sine of alpha cosine of beta. This negative sine of beta, I'll bring the negative sign out here. Cosine of alpha, sine of beta. This is our sine difference identity. So this is our difference identity. Okay. Let's do the cosine identity for difference. So I'm going to start with cosine of alpha plus beta equals cosine of alpha cosine of beta minus sine of alpha sine of beta. Okay? Similar to what we just did, I'm going to go cosine of alpha plus negative beta equals, and let's make the substitution. Cosine of alpha, cosine of negative beta, minus sine of alpha, sine of negative beta. So we have these two identities here. I'm going to plug those in. So cosine of alpha minus beta, there's our difference identity. Cosine of alpha, cosine of negative beta is just cosine of beta, minus sine of alpha, and I know sine of negative beta is negative sine of positive beta. Okay, let's clean this up. Negative and negative is positive, and I end with sine of alpha, sine of beta. This is our cosine difference identity.